This is third question about fundamental theorem of calculus. This is moderate level, but it can be a little bit difficult. But overall, I would say that it's a medium level because, first of all, understanding of this fundamental theorem of calculus, it's part 2. The domain is fixed over real numbers. Secondly, because computation work, people can make mistakes and lose partial marks easily for that when it can be complicated functions like polynomials with multiple components and different powers and whatnot. So let's proceed. Recalling fundamental theorem of calculus part 2 was that got an integral, say, going from a to b, and there's f at x, d at x. We are safe to use x because these are just numbers and there is no variable here. That means f, and we can plug in, this is the antiderivative of this function, of the later value, plugging in the later value, subtracted by the earlier value beginning of the interval. So once again, part 1 establishes this relationship that this is equal to f at x, meaning they are inversely related. This has to do with taking the antiderivative of that, and that has to do with taking the derivative of this without this hyphen here. That's the notation for derivative. So in this case, we need to determine the antiderivative of this function. So this is f at x. We need to come up with f at x. And we know that this is trigonometric function, and it's the typical form for secant. When you take the derivative of secant x, then you get this expression. You can prove this converting this into 1 over cosine and taking derivative of that, but we won't do that here. There's trigonometric functions, easy formulas for shortcuts to save you time on the test, and I believe that when you have these tests, the professors will often provide you with a sheet of paper where all these various different trigonometric functions are listed. So you can just plug them in and put it in. Usually when the questions they evaluate the integral, they will not give you anything that you cannot use from that list of easy shortcut trigonometric function formulas. So here, this is one of them. It's a very typical one. This involves, so next line it will be secant. So this will be f. We can just write this for clarity's sake. Because f at x is secant x, we can say secant pi over 3 minus secant 0. What that means is another notation would be like secant x. This is integration notation, pi over 3 upper bound going at the top and 0 at the bottom. So that's equal to that. Secant is, just for a review, to go over all the basic elements for those who cannot remember from before. This is equal to inverse of cosine. So this will be cosine that, and 1 over cosine 0. Using the special angle and unit circle, say this is x and this is y. Cosine 0, this means 0. And when cosine is 0, it's equal to 1. Pi over 3 uses special triangle. Pi is 180 divided by 3, that's 60. So you have a triangle that looks like this where it's 60 degrees. I'll just show in the degree mode. It's a right angle triangle. It is a triangle of equilateral triangle where it's 2, 2, and 2. So this is 1. Working with Pythagorean theorem, you get root 3. So cosine has to do with this adjacent over hypotenuse, so it's 1 over 2. So this is equal to 1 over 2 minus 1, which is equal to 2 minus 1, and the answer is 2. Such a nice number. So area under this given function, secant theta times tangent theta d theta over the interval going from 0 to pi over 3 is 1. Basically, this has to do with using the part 2 of the fundamental theorem of calculus.